Okay, so as I was saying, from our source code, we use streams to output to screen or input from keyboard. We can do the same thing for hard drives. We can output to the hard drive, input from the hard drive, and use that in variables in our program. And if we really want to look at it closer, then we're actually, from memory, we will output to screen or input from keyboard into memory, from memory out to hard drive, from hard drive into memory, and streams into our data variables in our program, right? So let's go ahead and start with an example. Okay, this is what I was recording for the video. Let me see. I lost it. That's should not have closed it. I should have deleted that stuff. Where was it? I think it was this. No. Yeah, this one. Yeah, so for this week's homework, I posted a video with tips, so that's what that was about. Okay, what are we working with? Let's work here. Well, actually, not this one, right? I always do that. It's this one. Okay, so it's module 8. So I go to SRC examples, CMake list, and module 8, remove the pound sign from the CMake list. And I don't have to do anything for the test case. We will not be writing test cases for this, mainly because when we are working with external systems, we do not connect to databases, or we do not connect to hard drives, like write to hard drive and read from hard drive. Instead, what is done in that point is in-memory lists are created, but I'm not going to do that because it'll take too much time. Okay, so let's go to I'll start here, temperature.h. Okay, so let's create an example to read and write from file, right? So actually write and then read. Okay, so we'll create a function here, and this is a free function. Okay, so we'll name it generically write to file, and then include temperature write to file. Okay, I stated that we need to use, I have them vice versa, right? No, I do. We need to use fstream, so that's file stream. So I've included that one there. And then I have to create a variable for it, right? So what I'll do is I'll say of stream, or output file stream, out file. So I create a variable, and then I will say out file.open, and then some name, I guess names.dat, DAT, I guess here. And maybe we shouldn't do this, but oh well, I did it. We should probably use a constant. We'll use it for the next example, because that way we won't make errors, right, in spelling the word in the other function. Okay, so we'll say writing to file. This will happen like very fast, but I'll still show the steps. So I'll be using that one quite a bit. So using cout, and I need to make sure I include iostream. Okay, and we can simply say out file, and then we use those operators, and we can write the name Joe and Mary and John. So we want to write those 3 lines out to file. Something very simple. Afterward, we can say close file. Maybe we should also say like open file. And we open the file, we use the file, and then finally we close the file, right? We don't want to leave file handles open. And that's what we do. We go to main. Actually, let me go to CMake first, and let me click on this, configure projects. That way it recognizes module 8 as a C++ project. Okay. Include temperature.h, write to file. And we go ahead and run it. The file will be written where our executable is. So we can get the executable from here once it completes executing, right? So we can copy all this up to here, Control C, open Explorer or File Explorer, paste the path, and then we see names.dat, edit with Notepad, and notice Joe, Mary, and John have been written to file. And then we can go ahead and close it. And we come back over here. And that was how you can write basic text file. And you can write also binary data, meaning it'll be computer language that we will not be able to understand, and then we could read it back in. But we will stick to basic file output and input, mainly because industry focuses more on databases, right? Unless you work like for data transformation companies. But usually there's so many tools out there that they don't want you to waste time creating a utility that writes and reads from files. Instead, you'll use a library that's pre-written where you just point and click, and then it does a transformation for you. So that's the main reason I don't spend a lot of time in file input and output. Okay, we'll just have like 1/2 lecture and that's it. Okay, so what we want to do is read from file. So then we can come here, read from file. And then we go ahead and write that piece of code. So input file stream, in file, open, and this is where I was saying it's better to use a constant so that we won't make a typo here, but I didn't, but it's okay. And then we need a string to read each name. We check if we can read the file, so we say if open read from file, let me see here, open file, and if we are here, we can say while in file, oops, I misspelled this one, and we use it just like cin, so we can say while in file name, then cout name, and then we close the file handle in file dot close. So we come over here. So in the book, chapter 13, right? That's first half of 13. They talk about file input and output. So there's different modes of opening files. Meaning like you can open for text, that's the default. You can also open it for binary, meaning like machine language output, and then you will have to read it back in. And then you can open for remove the file regardless, right? So if names.dat exists, we're just going to overwrite it. The other one is append and add end. And there's several other ones. It's in chapter 13, right? But I'll just focus on the basics, okay? Okay, so we go to main, and then we are okay. Let me read from file. And when we read it, we should see this, right? The names are displayed for us. So let's go ahead and go to main and run terminal. So we were in the delete file mode, meaning if the file exists, just overwrite it, right? So we open the file, we write to file, we close the file, and then we go ahead and open the file, read from file, read each entry, Joe, Mary, and John, and then we close the file. And we can come up here and verify that it's in delete mode, right? So if the overwrite mode, so if the file's there, it just deletes it, creates a brand new file. Okay, I think it's APP for append mode, and their function parameters you send into this section here. When you open the file, you would put commas, and then you think you do something like this, like append 8, but I don't cover that stuff because don't think it's, I mean, that necessary out in the industry, right? And reading and writing from file, there's so many libraries out there that if you need to do that, you should be able to just Google that, as opposed to trying to learn the object-oriented concepts, right? So that's why I focus more on those concepts, because those are more difficult to learn. Okay, questions here? Let me go here. Sorry, I hadn't looked at the questions. Homework 10 is the last assignment. The red image is a hard drive, yes. That file is just a text file. You should be able to write with this library to the Replit cloud compiler. Why did we use string name in the while loop? We need a variable to hold the data we're reading in. Remember, this one works like cin. So into name, right? So read from file and save it into name, and then we display the name. So this one works like cout, out file stream. In file stream works like cin. So remember, cin reads into variables, so we are reading into the name, and then displaying, come again, read, overwrite the name with the new value, and so forth and so forth. And this is what we get here: Joe, Mary, and John. It should, I mean, it should have write permissions. I mean, otherwise, how does it create the executable, right? And the file's created in the executable. So you would have to do what I did. You would have to you go to Replit and find out the path to where that file is, and then you would be able to find it, right? So usually in Replit you're housed here. So then if you go one back, you should find this build directory, and you go into that build directory, navigate to src examples 08 module, and that's where you will find the output. And if you don't know how to navigate, then you can just do a Google search like Unix change directory commands, and then you'll get like a short demo. It's very simple. It should take you maybe 5-10 minutes to figure it out. Okay. Okay, so what did we just do, right? We used the file streams to output file, and we used input file to read in from file, right? So this is what I was saying. Like usually nowadays, like when they're doing data conversions, there's database utilities. Like Oracle wants you to use their database, so they have utilities that can read text files. DB2, SQL Server, the open source one, Postgres, MySQL, all of them have utilities because they want companies to use them, right? So then they read from files into their databases, or maybe like out from their databases into files. So you don't have to write any custom code for that. Okay. So we wrote Mary, Joe, Mary, and John, right? So then we would have like Joe, Mary, and John, right? Individual chunks in the hard drive. If we are writing a record, like a class that has these 3 data members, ID 1, pay rate 20, and name Joe, then it would write them like this, like 1 here, and then 20 here, and then Joe here, and it would be a sequential chunk of the hard drive. So just imagine how we draw diagrams for the stack, right, where they do sequential. So then it's more efficient to choose a space in the hard drive that's sequential to write out and then to read in, right? Otherwise, the algorithms that go and read data from hard drives would have to be jumping all over the place to find the records, right? We do not provide an example for delete. The book does, if you want to look at that. Mainly because once you delete, then you have to do some coding, which I feel students really don't get much gain from, right? So you would have to like output this, or delete this, create a new file, output this to records to a new file, and then this to records to a new file, and then finally delete this file, and then you have the new file, right? So I mean, if you ever have to work extensively with files, that you know my email address, I'll be glad to help you. But so far, no students have ever emailed me about it, right? So, okay. I've talked about this, right? So include the F stream, open the file, use the file, close the file, right? Kind of like with memory. Create the memory, use the memory, delete the memory. Why? We don't want to have to leave a file handle open, because then another piece of the application might want to use it, and then we would run into issues, right, with our program. So that's why databases became more popular, because there's APIs and they're better at working with data than files are. Okay, so we have this diagram here, and temp is temperature. So we have a temperature class, and then we have a temperature data class. So the temperature class has two variables, an hour and a reading. So they're taking somebody's temperature, and then they record the hour and the reading. And they create, each time they take a temperature, the applications create a new object. So we would have a vector of temperature objects here. We want to loop or iterate through the vector, output each temperature object to file, okay? And then we want to do the opposite. We want to read each record, create a temperature class first, add it to a vector, do the same thing for the second one, read, create the object, add to vector, the third, the fourth, and the fifth, and then we recreate the vector so that our application can use that vector. And this is what you'll have to do for your tic-tac-toe homework. You'll have to write out the games that are played for tic-tac-toe 3 and tic-tac-toe 4. So some of them will have 9 outputs, including the spaces. If you are not using spaces, I recommend that you use spaces. I think there was a couple of students that initialized all the pegs to like the quote without a space. So if you write that out to file, then it'll be hard to determine the last character, which in your case will be the winner, right? So if you don't do that, then you have to create logic to determine who the winner is. So you don't want to do that. Just save the winner out to file and then read it, save the winner to your class, and then you don't have to write logic to determine the winner. Okay, so this is our next example right now. So this is what we will do right now. So we have to create that class. And the class is very simple, like it just holds data. And we will do it here. If not defined, temperature header, then go ahead and define it. These are our header guards. Every time we create a class from now on, we want to create them because they'll eliminate the compiler from thinking every time we include, we're wanting to create the same class again. The compiler will give us an error in that instance. Class temperature public, and then we have a save, I'll say temps, save temps, and this one will have actually no, this one has I was thinking about the data class, integer hour double reading. We are going to read those arguments into a private variable that we've not created yet, and into a private reading variable that we've not created either. Empty code block there. Private integer hour double reading, right? Those are the private data members. Once we do that, notice now Visual Studio is happy with us. Visual Studio Code. Okay, and that's it for a class. Like, we're just holding data. Nothing that should shock anyone. Okay, so then we go into temperature data, and if not defined, temperature data header, then define it. And if temperature data, okay, let's go ahead and include temperature header. We have a public access specifier, and we will create the save temps function. And this one, since we will be using a vector, we need to make sure we include a vector here. And while I'm at it, we will also use string. So let me go ahead and add string. And here we'll say, let me see, is it, yep, a vector of what? Vector of temperature. Reference temps. And then we say, okay, I want to return a vector of temperature objects, and we'll say get temps. We have one private access specifier string file name. We initialize it to temps.dat. This is a simple text file. And now we need to write code for these two class functions, for save temps and for get temps. And we come here. Actually, not that one. Temperature data. If you copy and paste like I did as you're following along the example, make sure you link these functions to the class, right? So we have to put temperature data : so now it's a class function. Remove the semicolon from the end, this one, and then we do the same thing here. We have to say you are part of the temperature data class. And then if we want to validate that we've done it correctly, we know we created a file name, private data variable, or get temps, save temps. I mean, so save temps, you can say get temps, right? If you see it, that means you've done it correctly. File name, you see it, you've done it correctly. And if you're over here, you can do the opposite. You can try to access save temps, it's there, and file name, it's there. So then you've got the includes and the class domain or scope set up correctly. Okay, so here we output the vector. That's what we want to do, write code to output the vector. So we can say let me go ahead and include fstream, and then I can say out file, right? So outstream, out file, file name, that's a string we created, dot open, actually dot open, right? Dot open, and this is where we put the parameter in the open function. And then we can start looping through our vector. So we can say for auto temp and temps, that means loop through the vector, out file, temp dot excuse me, temp dot get hour see temps. I need to drink some water. Okay, temperature. Well, it only does what we want it to do, right? So we don't have the get hour and get reading functions. So we can say here get hour const return hour, double get reading const return reading. Okay, so now those functions exist and we can use them. So we can come back to here and then this should be okay, right? So now they exist. Out file temp dot space, and then out file temp dot get reading, and then out file new line. We could have done it all in one out file statement, but I opted to do this instead, and then a new line. Finally, before we exit, we say make sure we close the file handle, and this code right here will read the vector, loop through it, output each pair of hour and reading in one line until it writes all of them. And for get temps, what we'll do is we will now do the opposite, right? We have to read the file, get the hour and reading for one record, use those as parameters in the temperature constructor, recreate a temperature object. After we create it, add it to a vector we will create here, and we do that until we loop through all the records in the file, and then we'll have a vector of temperature objects we created, and then we return it to the user. Okay, so vector of temperature, and we can call it temps, and before I forget, we say return temps, and we write the logic in here to read in from file. Okay, so we need in file stream in file, open the file name. We will need a local integer variable for hour and one for reading. And then we can say if in file is open, then we can start looping and going through that logic that I explained, right? So we're like, okay, so I can do while in file into hour and into reading, and notice how easy the library makes it for us, where we don't have to worry about the new line characters. The in file stream takes care of that for us. We have the hour and the reading. Let's create a temperature object, temp, and we say hour and reading. So we've created the temperature object. Let's go ahead and add it to temps vector by doing a pushback of temp. And we do that until the loop exits, and then finally we come here and we're like in file dot close. Spacing's off. There we go. Okay, so this should recreate the vector for us, and then we can demonstrate this in main. So let me go to main. Temperature data. So we can say vector of temperature, and we can say out temps. And we can go ahead and initialize this. So let's initialize it. We can say create a temperature object, number one, reading of 98.9. The second element is another temperature object, number two, hour, 99.9. And then another one, number three, 98.7. I'm just making this up. Another temperature object, number four, 99.1. Another one, number five, 99.5. And then the last one, 99.6 or something, right? So 6, 99.6. So we created a vector of temperature objects, and this are the initial elements in the vector. So we have 6 of them, right? 1, 2, 3, 4, 5, 6. we can create the data object, temperature data, and then we say, okay, let's go ahead and save the temps. We use the temps variable as a parameter for that class function. So that will write out this vector right here. And then we're like, okay, let me create another local vector here of temperature objects. I'll name it in temps, and I'll say you are equal to data.get temps and that should return the same exact vector for us. And then we can say, okay, well, let's go ahead and say for auto temp in temps cout get hour and oops and reading new line, and then we can compare the output to this and it should be the same. Okay, let me see if there's questions here. We don't want to, so why do we want to use vector reference? Because we don't want to create a copy of the vector in memory. So that's why we do that. We already have it here. So then we just tell C++ use this list instead of copying this into another list. Okay. Run in terminal. Should have put some output, right? Okay, so our output 198.9, 198.9, 299.9, 98.7, 99.1, 99.5, 99.6, and I can always copy this path right here into File Explorer. Well, actually, I have it here already, but I will anyway, right? So there it is, 419, 614. Let's go ahead and open it, edit, and notice we wrote the records out to file, and then we read each record, created a temperature object 1, 2, 3, 4, 5, 6 times to recreate our vector. We saved the vector into a local vector of temperature variable, and then we loop through it to output it. And you'll be doing something similar to this for the tic-tac-toe program, right? I'll create a video to talk about the gotchas that you'll run into for that assignment. For this example, I mean, we could use const if we wanted to. I mean, that would probably make it correct, but my main goal here was to just show you how easy it is to write a vector. Well, maybe not easy, right? But how straightforward they've made it for us, right? And if we want to make this const, then we can go ahead and make it const. Like nothing's going to happen as long as we make both of them const. Right, so all the marks are gone. So okay, so questions? I don't know if you've seen examples like this where, I mean, the first example so trivial, right? Like it's kind of like, okay, sir, so that's write a file. You know, where's that guy? temperature. It's kind of like, okay, so that's how I write a file, you know, whatever. But once you start like diving deeper into like the power of object-oriented programming, right, then you're like, oh, okay, so that's maybe how the database APIs kind of work, like, well, kind of, right? The example I've done is very simplistic compared to database APIs. Questions here? Okay, no questions. So what I will do right now is I am